Okay, this is our Monday, November 2nd lecture for college algebra. The topic we're going to cover is linear inequalities. I've already given you a reading section on the class website. Remember the website is rejoicealways.net. And you can see the links to the homework problems there, as well as the reading section has lots of great examples. What I'm going to do today is work several examples for you, similar to the ones that I'm assigning for homework, and I'm going to pull my examples off of the author's extra problems or assignment problems that have no solutions. So let me show you how to do several linear inequalities. It's not too hard. Some of y'all may feel like you've died and gone to algebra heaven compared to what we've been doing. Let me work a few of these. So that's an example of what we call a linear inequality. And what we're doing here, when we have an equation, if I had 10 times 3 plus x is equal to 9 times 2 minus 4x, we'd solve that equation. It'd be real easy to do. And we're looking, if it were an equation, we're looking for the one number for x that would make that true. But with an inequality, what we're asking is a little bit different question. What region of numbers for x, or set of numbers, or kinds of numbers, could I put into this expression for x so that 10 times 3 plus any one of those numbers would always be greater than or equal to 9 times 2 minus 4 times that same region of numbers? And so that may not have made a lick of sense, but let's do the problem and then it'll make sense. Here's the key thing. With one exception, you use your equation solving skills just exactly like you did for equations. Add the same thing to both sides, multiply or divide both sides by the same number, with one exception. And when I get to a problem where you need that exception, I'll show it to you then. But for right now, if this were an equation, I would multiply the 10 times each of the terms there, the 9 times each of the terms there, so that I can get all the x terms on one side and the numeric terms on the other. So let's do that. We'll distribute the 10, across each of those terms. That would give me 30 plus 10x is greater than or equal to 18 minus 36x. I want to get all my x terms on one side, numbers on the other. I'm going to add 36x to both sides, just like I would with an equation. That gives me 30 plus 46x is greater than or equal to 18. I'm going to subtract 30 from both sides. And I get 46x is greater than or equal to negative 12. Divide both sides by 46. And simplify your fraction. 2 will go into each of those. You'd have x is greater than or equal to negative 6/23. It's not a pretty answer, but it's the answer. And what this means is any number greater than or equal to negative 6/23 would make sure that the expression on the left is always greater than the expression on the right, greater than or equal to that expression. Usually on these problems we'll want to graph our solution, and the way you graph that, just locate your negative 6/23 on a number line, put a circle around it, make the circle solid because of the greater than or equal to. That indicates you are including the negative 6/23, and then all the numbers greater than that would be the numbers to the right. So there is a number line graph that goes along with the algebraic statement of your solution. Some textbooks will also want you to write your answer in what is called interval notation or interval format. And the way you do that is just say it'd be all numbers. The way you indicate greater than or equal to with interval notation is you use a bracket right here, and it's all of the numbers including negative 6/23 on out to infinity. And so there would be your answer in interval notation, there would be your answer as a number line graph, and there would be your algebraic answer. And there's an easy example of a linear inequality, and many of your problems will look like that. So let me erase that and pick out another problem. problem 4. Now, I picked this one out because it's just a mess with all the fractions and everything else in it. Let me make a suggestion to you. I'm going to do this what I think is the quickest, easiest way. It's the way I've shown y'all to solve equations whenever we have a bunch of fractions involved in the equation. I lovingly call it the IHF SOA method. I Hate Fraction Society of America. I'm the president and founding member. I'm going to first multiply the 2 times each of the terms here, the 4 times each of those, and then I'll tell you what we're going to do after that. So let's start on this. 2 times 1/6 would be 2/6, and then reduce that fraction to 1/3. It just makes everything easier. Multiply the 4 times each of these terms, and that'll give you 8. If you multiply 4 over 1, if you're good with fractions, you just do that in your head, it's a piece of cake. If you're not so good, write it down on scratch paper or something. 4 over 1 times 7/18, and say to yourself, 2 will go into both that factor and that one, and nothing else, no other common factors will cancel, and so it's going to be 14/9. Okay? So, or just use a calculator. Multiply 4 times 7/18 and make sure you get your answer in fraction format. Now, we could go ahead and combine all the like terms. There's going to be a lot of having to get common denominators and things like that. I despise that, and I think a much quicker, easier way to do this is look at each of the fractions in the problem. I have a denominator of 3, of 3, of 9, of 9. If I have so many thirds and so many ninths, what would be the lowest common denominator? Well, the lowest common denominator would be ninths, or 9. So I'm going to multiply each side of this equation by 9. And this is going to be slickered and boiled over. When I multiply 9 times 2/3, the 3 would cancel with the 9 and be 3 times 2 would be 6. When I multiply 9 times 1/3, that's 3x. When I multiply 9 times 1/9, I get 1x. 9 times 8 would be 72. Here the 9's would cancel and be 14x. When you look at that, no fractions, sweet, easy, simple. That's why we use this particular method of solving these. I've demonstrated this in class numerous times throughout the semester. Okay, let's combine our like terms on the right. X minus 14x would be 72 minus 13x. Add 13x to both sides. You have 6 plus 10x is greater than 72. Subtract 6 from both sides. You have 10x is greater than 66. Now, I'm about out of room on this board. You've got all that on the video. You can always back it up and look at it if you'd like. If you wanted to make a copy of this so you'd have a sample practice problem, you could do that. But I'm going to erase everything underneath the original problem and just bring this up and keep going. So I have 10x is greater than 66. Divide both sides by 10. Reduce your fraction, that would be 33/5. Just divide each of these by 2. There's your answer algebraically. Any number greater than 33/5 substituted in this expression would always make sure the left-hand side is greater than the right-hand side. Graph your answer, and all you do is just locate 33/5 on a number line. Notice on this problem I used a hollow circle around the point 33/5 because it's strictly greater than. That's the way with the number line graph. You indicate that it's anything getting real close to 33/5 but never equal to 33/5. Remember I showed you one other way in the last problem? Wow, the last problem to write your answer. That would be interval notation. The way you would write this one, because we're not including the endpoint 33/5, we will use a parenthesis instead of a bracket. And this interval notation means all of the numbers starting greater than 33/5 and on out to infinity. Use a parenthesis if you exclude the endpoint, if you have a strict inequality. On the last problem, use a bracket if you want to include your endpoint, if you have a solid circle or a greater than or equal to. And there's your solution for number 4. Let's do another one. Let's show you something a little different. Number 6. Okay, if you've never seen this before, it definitely looks a little weird. But it's easy and it's not hard to deal with. Often, when you're working problems with inequalities and you have ranges of numbers that you're looking for that match a certain attribute or criteria, it turns out that you want a region of numbers between two extremes. I just want to know what numbers x will make this expression, 7x plus 8, always fall between -4 and 1, and it can even be equal to the 1. And all you do to solve it is think of it as a 3-sided equation. You have the left side, the middle, and the right side. And the same equation solving rules apply. Whatever you do to one side, you do to all 3 sides. So I want to isolate the x, get it in the middle. So I'm going to subtract 8 from all 3 parts. That give me -12 is less than 7x is less than or equal to -7. And then divide all 3 parts by 7. I want to get to plain old x here, so I'm going to divide everything by 7. Divide each part by 7. Now, this is a good common notation. X is all numbers greater than -12/7 and less than -1. On a number line graph, it would look like this. Put your smallest number on the left, your largest number on the right. Note your inequality signs. Less than or equal to means we're going to put a solid circle around that endpoint. X is strictly greater than, a hollow circle there, and shade all the numbers in between. And so on a number line graph, this is what we were looking for. What range of numbers could I use for x that would make sure this expression is always between -4 and 1? And that range of numbers is all numbers on the number line graph between -12/7 and -1, including the -1. How do you write this using interval notation? Use parentheses on the left, all numbers from -12/7 up to and including -1. So use a bracket on the -1. And that's a 3-sided inequality. And we're going to see this again when we get to doing absolute value inequalities. We'll see this idea again. But we just need to get this skill down right now. Now, it will probably confuse you a bit, but I'm going to go ahead and say it anyhow. Kind of a preview to what's going to be coming up when we do absolute value inequalities. This notation right here can be written another way. This is a shorthand notation. The fuller form of writing it is to say x is less than or equal to -1 and x is greater than -12/7. When mathematicians use the word and, especially with inequalities, it's used in a technical sense. It means intersect. This is the and means the intersection of this set of numbers and this set of numbers. And again, this is not needed on any of the problems we do in this assignment, but we will need it later. So let me show you something. This and this are 2 ways to say the same thing. I hope you have that. Well, you've got that on the video. You can go back and look at it. Maybe you want to write it down. But pause the video, write it down. But let me show you how, if you saw it like this in the first place, how you would handle it. The way I suggest to my students to handle an intersection of 2 sets of numbers is draw the graph for the first set. What would the graph of all numbers less than or equal to -1 look like? Well, -1 might be there. It'd be solid. It'd be all of the numbers throughout to -infinity. That's the set of numbers that inequality represents. What would the graph of all numbers greater than negative 12/7 represent? Put it underneath it. Negative 12/7 might fall there. Put a hollow circle around it and shade in all the numbers greater. Now, what I want is the intersection of these numbers and these numbers. The way you define an intersection is an intersection is like a real snooty sorority or something. The only people they're going to let in are people who match all their requirements. If they miss out on just one, they're not going to let them in. So intersection is a real snooty, picky operation. And so I want the numbers that are in both of these sets at the same time. If it's out here, it can't be there. If it's back here, it can't be there. So looking at these, just line them up. What numbers are in both of these sets? Well, the smallest one would be negative 12/7 with a hollow circle. The largest would be negative 1 with a solid, because negative 1 is in this set also, isn't it? And it's all the numbers in between. Well, doesn't that look just like the number line graph we had on our answer, the one that I erased? And certainly it does. And that's just a little demonstration. Now, it's of how this notation is really a set operation between two sets of numbers, and it means the same thing as you put your x in the middle, representing the middle of the number line, is less than, what's the largest number here? Well, the largest number, see, negative 1 is larger than negative 12/7. So it's less than or equal to negative 1, and it's greater than negative 12/7. And that's the right way to read that. Now, for all of the problems that you see a three-sided inequality, that's understood and it's in the background, but you don't have to use it, see? Just do the same thing to all three parts, get your answer like that, and graph it like that, and you'll be good. Let me do one more example that illustrates the difference. Remember, at the start of this lecture, I said that you solve inequalities like you do equations with one exception or one difference. Let me show you an example of that exception. Problem 8 looks like this. And we're going to run into an oddity here. We're going to run into the one exception that I warned you about. I want to solve this for the variable m. I want to get the m by itself, so I'm going to do the same thing to all three sides. I'm going to subtract 4 from all three sides. And that'll give us negative 16 is less than or equal to negative 11m is less than or equal to negative 1. Now, in order to solve this for m, I need to divide all three parts by negative 11. And that's the time where you have an exception when solving inequalities is different with equations. With equations, you'd divide everything by negative 11 and life would go on. You wouldn't do anything special. With inequalities, any time you have to use the technique of multiplying or dividing both sides or all three sides of a three-part inequality, multiplying or dividing by a negative number, then you've got to reverse the order of the inequality. So here's what we're going to do. I'm going to divide everything by negative 11, but watch what I do. I'm going to reverse the order of the inequality, turn it around, and reverse the order of that inequality. Now, you have to do that. If you do not, your answers will always be backwards. Instead of it being the correct region of numbers for the problem, it's going to be the opposite of those. It's going to be the numbers on the number line that don't satisfy this. So here's what we're going to do. I've got negative 16 divided by negative 11 would be positive 16/11. Negative 11's cancel. Is greater than or equal to m is greater than or equal to 1/11. Now something odd has happened here. First of all, these symbols are really backwards. Second of all, 16/11 is the larger of these numbers. 1/11 is the small number. 16/11 is the largest. Technically, this is correct, but it's algebraically impolite to write it this way. So here's what I'm going to do. Notice the signs. M is greater than or equal to 1/11. I'm going to reverse this. I'm going to put the smallest number on the left, and I need m to be greater than that. So see, the symbol gets reversed again, and is less than or equal to 16/11. When you use this three-part notation and you get it down to where you have your variable by itself, you always want to put the smallest number on the left and and the largest on the right. So it's no big deal if you end up with something like this in the process of getting your answer. Just be kind to someone and write it like that at the end. All you do is the m is greater than 1/11th, the m is greater than 1/11th. Just put the smallest number here, the largest number here, and your variable in the middle with the symbols going that direction. Now let's graph this and get our answer in interval notation. So all numbers between 1/11th and 16/11ths, the 1/11th is on the left, the 16/11ths is on the right. It's greater than or equal to and less than or equal to, so solid circles, and there you go. And then finally, how would you write that answer using interval notation? Everything from 1/11th to 16/11ths, and notice we use the brackets on both sides because we include the endpoints. And there's your lecture on linear inequalities. The assignment is on the website, and y'all have a great day Monday, and remember, you don't have to come to class.